Here we go. Conjecture. Can anybody raise their hand and tell me what a conjecture is? Oh, so we're totally in math, so I really don't care about like English grammar stuff. Okay, Jake Jensen. How does he know that?
I knew that as well. It says it.
Look at this right here. Whoa. Whoa.
Oh my gosh, it's so so why did we need our whiteboard?
I never said.
Why did I get that?
That's
what she said.
Tyler. Jonah. Turning to this page in our journal. Do you know?
What page is this page?
Okay. Now we're going to talk about the difference between inductive and deductive reasoning. Okay. Inductive reasoning, we are going to find a pattern in specific cases, and then we're going to write a conjecture. Like, sort of like, okay, I'm looking at this and I'm going to tell you it looks like this is true. Okay. Biconditional. We're having some trouble with biconditional statements. Okay. So what do I mean by we're going to find a pattern in specific cases and then write a conjecture? Okay. So let's say I have this pattern of
I was gonna say something like that.
numbers.
Yeah. I literally was gonna say you have 2, 4,
None of this requires you to talk. Ben, your back should never be turned towards that front wall. Your shoulders need to be facing the wall. Okay. Nature, you're gonna fall one of these taking pressure.
I am.
Tyler.
Are we ever gonna do like numbers? Anything involved with numbers?
I see numbers on the board right now. Okay, so here I have a pattern. 12, 17, 22, 27, 32. I want you to silently think about what the next 3 numbers in our pattern would be. Raise your hand if you think you know. Emily.
37.
Wow. Keegan, how did she come up with those? So Emily and Keegan have noticed a pattern that we started at 12 and every number is just 5 more. Do you agree?
Yes.
Okay. Here's our next one. Just silently write it down and think. Silently write it down and think. We will. I'm giving people an opportunity to write it down and think about it. Aiden, do you know what the next 3 numbers are? Okay. Tyler, what are the next 3 numbers?
36, 49, and
Carson, how did you get those numbers?
it's all square numbers, but I thought it was something different.
It is all squared numbers. 1, 4, 9, 16, 25 are all, we call them perfect squares.
I got like
Okay.
the same thing, but I did like 1 plus 3 is an odd number, and then 1 plus 5 is an odd number, or 4 plus 5 is a, so I just kept going up by the odd numbers.
That is amazing, isn't it?
Is that actually how it works?
Well, think about the Pythagorean theorem. Never mind. Let me just reel that back. Yes, these are perfect squares, but there are patterns within the list of perfect squares like Adri and Carson.
It was all Carson. It was all me. I also thought that.
Yeah, she was agreeing with you. Okay. So we made a conjecture. We figured out that these are what the next 3 terms were going to be based on. What? Oh, okay, based on our pattern. Okay. I thought Zach had something to to add. Okay. Now, a counterexample we've already talked about, okay, but we're going to use them quite a bit today. A counterexample is a specific case for which a conjecture is false, okay? So today, again, you're going to be given times where if it's not true, provide a counterexample, okay? You got to do that in your homework last night, right? Okay. All right, so let's talk about deductive reasoning. Okay, so let's come back up to here. So deductive reasoning, okay, uses facts, definitions, accepted properties, and the laws of logic. And guess what? I'm going to teach you a couple laws of logic today. Anything for you, Aiden.
Wait, what does that say? Did that say?
Properties. I like all of my students.
Even me?
Even you, Ben.
We did the scale until you said buttercup.
How else?
All of us know she did. Random. Oh, that was last year.
There is no seating chart that will keep Ben from talking. So,
Yeah, put me in the back. Yeah, you should.
didn't I try that? Weren't you in the back last time?
Make an island. Ben was on that.
But let's be honest, it's not just Ben. Jonah. Okay. Let's talk about some of our deductive reasoning logic laws. Okay, turn the page. Okay. So here are our laws of logic. Okay. So we just talked about deductive reasoning. Okay. The first thing we are going to talk about is what's called the law of detachment. Okay. If the hypothesis of a true conditional statement is true, then the conclusion is also true. It doesn't make sense. Don't worry, I'll give you an example. Okay. Is it specifically about this? Does it relate to this lesson?
Yeah, sort of. It could.
What?
You got tape?
Yes, I have some tape up here. Okay. So I have an example of the law of detachment. Okay, I want you to write this. Number 1, if a figure is a square, then it is
Quadrilateral.
a rectangle.
No.
Yes.
No. Yeah. No matter where's the square, rectangle's a different.
You are really called the law.
Okay. The square is a special case of a rectangle. But the definition of a rectangle is a parallelogram with 4 right angles. I believe a square meets those specifications. Ergo, a square is a rectangle. Well, then you would be wrong.
Wait, then is a rectangle not a square? No, a square is some equal size. No, because wait, no, here, explain. So in fifth grade, our teacher would always tell us that, I can't remember which one is what. One of them is the other one, but the other one's not that one. Yeah.
Agree, which is what was a part of your homework last night.
Square
Okay.
is a rectangle, but a rectangle is not a square.
Okay, so here I have 2 statements. Statement number 1, Carson. If a figure is a square, I know, and I'm just telling you, did you write this down? If a figure is a square, then it is a rectangle. Statement number 2, ABCD is a square. Write those 2 things down. And we're going to use the law of detachment to come up with a conclusion. Yes, be quiet and write it down. Dalton, you are not helping. Just be quiet. Okay, Bryce, what can we conclude from these 2 statements put together? If a figure is a square, then it is a rectangle. ABCD is a square.
ABCD survey.
Yes. Figure ABCD is a rectangle. We have a pattern, right? A figure is a square means it's a rectangle. Here I'm giving you a specific square. Then we know it's also a rectangle. Okay, this is an example of how we use the law of detachment. Okay. Okay. Then, Tyler, what are you doing? The law of syllogism. This is a fun one. This is what I like to think of as the transitive property for logic. You don't know what the transitive property is?
No.
Okay. If x equals y and y equals z, then that's the transitive property.
Yeah, I did that.
Okay,
You did that?
apparently.
You know what it is.
Perfect. Thank you. Now, here we go. We have if P, then Q. If Q, then R. Then we can say hypothesis P implies conclusion R. Implies.
You say equals to.
We're not doing equals, we're doing logic. If you need to think about that in your brain, Carson, to get it to flow, that's fine. Okay. Okay. You're writing this down.
Wait, do you know Morse code?
No. I expect more from you. I am waiting for it to be quiet before I give you an example of this. If 2x plus 4 equals 8, then 2x equals 4. Just write it down. You don't need to commentate. Statement number 2. If 2x equals 4, then x equals 2. Okay, so I'm taking colors here and I'm underlining all of the different statements. And if they match, they're the same color. So notice how 2x equals 4 happens twice, so I underlined it in red. Okay, what's happening here? This statement, I have if P, then Q. This statement, the hypothesis matches the conclusion of the first one. And we have a new conclusion, okay? Well, since we have the first statement's conclusion is the second statement's hypothesis, then we can conclude P implies R. So we can write if 2x plus 4 equals 8, then x equals 2. We can go from the first hypothesis to the second conclusion. Do you see how that flows together? Zach?
Yeah, I just have to like, why can't we just say that?
Okay, so I gave you an example that you can clearly see. It involves some numbers. We're not going to use numbers, okay? We're going to be using like phrases, okay? It's logic.
How is it not? I thought we were like doing shapes.
We will. You have a question about this?
Numbers or like sandwich chip bag?
It's going to be more statements. So I'm handing you 4 examples that we're going to do together. Okay, and you are welcome to stretch your mouth and write on these pieces of paper and keep them in your journal. I noticed that with our biconditional statements, people weren't really writing down the examples. And when they were trying to do their homework, they didn't have a lot to look off of. I just forgot half of it.
Some people copy don't tell us.
Okay, she's then we can, did you look at like my PDF of the notes to write down? Okay, okay, so you should have everything that we wrote down. Okay, okay, and if you have questions, then, okay. All right, so here we go. Some of these are examples of the law of detachment, and some of these are examples of the law of syllogism, okay? So I want you to go ahead and read through this first one. If a student attends LVMS, then they are a monarch. Joe attends oh my goodness. Do we know how to be in a classroom full of other people? It's not funny. No, I did not. And you know I did not. Okay, Zach, you are very excited about it. What do we know about Joe?
He attends LVMS. He's a monarch.
Okay. Joe attends LVMS. And if a student attends LVMS, we know that they are a monarch. So we can say that Joe is a monarch.
That's cool.
Based on the law of detachment. So I would put it just so that if you ever come across a time where it doesn't tell you and you have to pick, you have an example, or I believe in your homework tonight.
It's out of ink, so I'm trying to get it to go to the top.
Okay, I think you're done. Okay. I'm sure it's there. If in your homework it says, please use the law of detachment. Here is an example of us using the law of detachment that you can look off of. Cohen.
Yeah.
One would think.
Wait, I thought it was law of syllogism.
But when you miss points on your quiz, you're not gonna think so much.
He's not gonna be at all.
Okay, so if you think that this is common sense, I cannot wait to see your homework tomorrow and it's gonna be all right, correct? Okay, read this next one. If an animal is a dog, then it barks at the mailman. Rico is a cat.
So he meows at the mailman.
Rico does not bark at the mailman.
Did I ask anybody to talk? No. Okay. Jake, do we know anything about Rico? What? That's all we know.
And his name's Rico.
And his name's Rico. Is Rico gonna bark at the mailman?
No.
He's gonna meow.
I don't know. We have no idea. If an animal is a dog, if this said Rico is a dog, we could make a conclusion. Because we know that if an animal is a dog, then it barks at the mailman. But Rico's not a dog, so we know nothing. We don't, there's nothing that we can conclude.
Yeah, isn't a collusion?
He doesn't though. No matter what he does, he will not bark at the mailman.
How do you know? We don't have, listen. We don't have that, I mean, we could say Rico is a seal.
I have a cat named Rico.
Well, a seal can bark,
No, we got like
and,
bark,
right?
bark. Yeah, I want more than name a cat.
That's what I wanted. I put true. There's a fox can bark.
No,
They also did the
maybe just a dog and a cat.
I am gonna start handing out detentions for students who cannot keep their mouths shut. 10-minute detentions for students who cannot keep their mouths shut at times that are appropriate. Hey, if an animal is a dog, then it barks at the mailman. I would have to know something about a dog. I know nothing about a dog, so there's no conclusion that I can make definitively. Okay, Jonah, thank you for raising your hand. What?
Oh my God. He's folding under pressure.
You're right.
That's why we have no conclusion.
What?
All right,
That's why we have no conclusion.
this one's for my soccer players. If soccer practice is canceled, then you can go to the mall after school. If it is raining today, then soccer practice canceled. You have 30 seconds to discuss at a very low level with your neighbor. What is the conclusion if we can make one?
I decided.
Okay. Drew, can we make a conclusion? Yeah? Okay, so we can write if it is raining today, then you can go to the mall after school. Okay, we just used the law of syllogism. Spell it. Okay, so now this one was a little tricky because I put the P implies Q second. Okay, but notice how I have a statement that its conclusion matches a hypothesis. So when we write PQ, QP, since these are the same, we can go from Q.
Aren't they both P's? So does it mean?
That was a mistake on Miss Holman's part.
You thought it's not cool.
To R, from P to R. Colton.
So, I'm not trying to be disrespectful, but how does this relate to that?
Okay. Do you need logical reasoning skills to solve problems?
Yeah.
Okay.
Hence, but if we already know about like all the different like, but then we need to like go deeper into it and do all of this.
Okay. We're about to write proofs. Okay. And mathematics is based on us being able to prove why things work the way that they do. So before we get into writing proofs about mathematics, we need to talk about logic so that when we write proofs, we can use our logic to get from point A to point B. Okay, thank you. Because we're going to do the law of syllogism over and over, okay? This implies this, so then this implies this, so then this implies this, so then this implies this. Okay, so if we start here, we can end here. Okay, we're going to use this over and over here in a couple days. Okay, last example. If a figure is a rectangle, then all interior angles are 90 degrees. If a figure is a square, then all interior angles are 90 degrees. What's our conclusion? Okay, I like that. However, if we try to use the law of syllogism, we need to look for this. P implies Q, Q implies R, so P implies R. Is that pattern happening?
No.
Notice how by highlighted pink are both conclusions. One needs to be a hypothesis, one needs to be a conclusion. No, you don't have to draw this. Okay, so I really like highlighting in different colors. Now, maybe you're gonna do your assignment in pencil. So maybe you underline, squiggle, dotted line, circle, whatever you think is going to help you, okay? I would keep that just for examples, just wear it kind of like a bookmark for you, right? Your homework is the 2.2 student journal. So the rest of that page and the next. Okay.